Messier Object 78, or M78, is a beautiful object in space. It is a cloud of gas and dust lit up by the stars within it. We call this type of object a reflection nebula. M78 resides at 1,600 light-years away from us in the famous constellation of Orion. You may know Orion for its three-star belt. M78 is actually just a little north of those stars. The nebula is part of the larger Orion molecular cloud complex. This complex is a bustling hub of star formation. It's one of the most active star-forming regions in our galaxy. The European Space Agency's Euclid Telescope has given us an incredible new view of M78. Euclid is designed to study the universe on a grand scale. It does this by looking at vast areas of the sky in both visible and infrared light. Visible light is what our eyes see, but infrared light reveals what's hidden behind the dust. This is because infrared light can pass through dust clouds more easily than visible light. Euclid's image of M78 is much sharper and more detailed than anything we've seen before. It reveals a stunning tapestry of gas, dust, and young stars. The image shows bright, glowing clouds of gas where stars are forming. We can also see dark, winding lanes of dust where stars are still taking shape. Stars are born within dense clouds of gas and dust. Gravity pulls this material together, causing it to clump and collapse. As the cloud collapses, it spins faster and heats up. Eventually, the core of the cloud becomes so hot and dense that nuclear fusion begins. Euclid's image of M78 allows us to peer into the very heart of star-forming regions. The bright regions are where gas and dust are being heated by the intense radiation from newborn stars. These regions are like cosmic nurseries filled with new stars just starting their lives. While the bright regions in Euclid's image are impressive, the dark lanes of dust are equally important. These lanes are not empty. They are filled with cold, dense gas and dust. This material is the raw material for future generations of stars. Over time, gravity will pull this material together, forming new stars and planetary systems. The dark lanes also help to shape the nebula. They channel the flow of gas and dust, creating the intricate structures we see in Euclid's image. By studying these lanes, we can learn more about the conditions under which stars form and the role that dust plays in this process. Euclid's observations of M78 are even more powerful when combined with data from other telescopes. By combining observations from telescopes that observe the universe in different wavelengths of light, astronomers can obtain a more complete picture of the nebula's properties and processes. For example, observations from ground-based telescopes like the Very Large Telescope in Chile can provide high-resolution images in visible and infrared light, complementing Euclid's wider field view. Radio telescopes, such as the Atacama Large Millimeter-Submillimeter Array, can peer through the dense dust clouds to reveal the faint radio waves emitted by molecules within the nebula. These observations provide insights into the chemical composition and physical conditions of the gas and dust. Studying M78 provides valuable insights into the processes of star formation and stellar dynamics. By observing the interactions between stars, gas, and dust, astronomers can learn about the factors that drive the evolution of star-forming regions. For example, the bright, massive stars in M78 are relatively short-lived. As these stars age, they will eventually explode as supernovae, releasing tremendous amounts of energy and heavy elements into the surrounding space. These supernova explosions can trigger the formation of new generations of stars by compressing nearby gas and dust clouds. They also enrich the interstellar medium with heavy elements, which are essential for the formation of planets and life itself. The study of M78 and other star-forming regions helps us understand the intricate interplay between stellar evolution, the dynamics of gas and dust, and the overall evolution of galaxies. Euclid's observations of M78 are just a small part of its ambitious mission to study the universe on a grand scale. By mapping the distribution of dark matter and galaxies, Euclid will provide crucial insights into the nature of dark energy, the expansion of the universe, and the formation of cosmic structures. Euclid's data will help us address some of the most fundamental questions in astronomy and cosmology. What is the origin of the universe? How did galaxies form and evolve? What is the fate of the universe? The telescope's legacy will extend far beyond its initial mission, as its data will be studied by astronomers for generations to come. Euclid's observations will undoubtedly lead to new discoveries and a deeper understanding of our place in the cosmos. As Euclid continues to observe the universe, its observations will undoubtedly lead to new and unexpected discoveries. The telescope's ability to study both visible and infrared light, combined with its wide field view, makes it a powerful tool for uncovering the secrets of the cosmos. Astronomers are eagerly awaiting the data from Euclid's observations of M78 and other star-forming regions. These observations will provide new insights into the processes of star formation, the role of dark matter, and the intricate interplay between stars, gas, and dust. Euclid's mission is a testament to human curiosity and our desire to understand the universe around us. Its observations will inspire future generations of astronomers and continue to shape our understanding of the cosmos for decades to come.